Hello everyone, and welcome to another Eng 130 video tutorial. This will be a short little tutorial today, as I'm just going to show you guys a little trick. It's nothing major, and a lot of you may already know it, but for those who don't, I think it'd be nice to know, and it just also gives you extra practice with X and Y components. Alright, so that being said, let's get into the example. Alrighty, so looking at the example, it is as easy as I said it would be. So quite simply, it says resolve F1 and F2 into their X and Y components. So this example looks pretty tricky, but it's not. And the reason why it looks so tricky is because everything is at this angle 60 degrees right there. Everything is at that angle. So there's many things that we can do if we wanted to get it into the traditional sense X and Y. But I'm not even going to go into that, because here's the trick, and this is what you guys need to know, because I think this happened one year, and I forget which year. It was before I started doing this. But look at the axis right here. We got to look at our axis. Our axis is already at an angle. It is not at the traditional vertical and horizontal axis that we're accustomed to. So this question is actually really easy, because I'll just draw it here. This question is basically this right here. So we got our y-axis, got our our horizontal axis. So I'm just going to put labels to show which axis I'm talking about for each one. So this is going to be our y-axis. This is going to be our x-axis. And of course, color code the vectors. I know it's easier to see. We got F1, which will be a red vector. So looking here, we got F1 like this. Ta-da! We know its magnitude is 400 newtons. And we got F2, which is a blue vector, which comes down like this. Put the little arrowhead, and we're drawing it here. It comes perfect. So we know that this F2 is 250 newtons. And then we can finally place our geometry real quick. I'm sorry I'm going quick just to show you guys, but this is all review. If you guys aren't sure what I'm doing, I highly recommend going back to the previous videos. It'll show you everything. And this is 30 degrees. So now if I were to give you guys this problem right here, you guys would go, oh Clayton, this is easy. This isn't bad at all. And you're right, it's not. This is easy. So don't let that 60 degrees in the top corner up here fool you, because even though a question could have an axis that's like this, then yes, it'd be a lot more work. But the whole purpose of this one right here is just to show you guys, pay attention to the axis that we give you. And that goes for the midterms, the labs, because sometimes we're not going to give you the traditional axis. And it could be for a variety of reasons. One, it could be to make the question easier, as in this case. Having that axis makes this whole thing so much easier, which is great. And that's what we want. We want things to be easy. However, there could be sometimes where we give it to you to make the question harder. And if that's the case, I promise you I was not behind that. You can blame one of the professors. But this is also good because we can start to go over the X and Y components and show you guys the notations and stuff. So again, just I want to show you guys this trick, but we're still going to go through this. But just keep in mind that for now, just treat this as practice. The rest of this is just practice, because this is good to know. So we'll start with F1 here. So I'm going to switch to red. F1. So we're going to start with the X component. So we know that F1X is going to be equal to 400 times the sine of 30. And we type that all into our calculator, we're going to get 200 newtons. So the final thing to do for Cartesian vector notation, which again is why I think the practice is good, because this is a step that everybody forgets. I forget it sometimes, is just look at the direction. So we know that F2 is going something like this. F1X. It's going along the positive axis, so that's a positive value. So that's the one thing to keep in mind. We go F1Y is going to be equal to, again, the 400 times sine. Sine. Nope. I'm so used to the vertical being sine, but it's not. This one's cosine of 30 We type all that in your calculator, we're going to get 346 newtons. And then again, what we want to check is the direction of it. So we know that this one goes up like this. So we know that that one's also going to be positive. So that's F1, nice and easy. We go down to F2. So F2, then we'll go F2x, and I'm going to start a little bit earlier so I don't run out of room again. So F2x is going to be 250 newtons times, and this is kind of nice, cosine of 45 is the exact same as sine 45, so it's cosine of 45. But what's nice is this answer right here will also be F2y because the cosine and sine are the exact same. What happens is you get 177 newtons. And like I say, the cosine and sine are the same, so we know that F2y is going to be 177 newtons as well. But now again, we've got to check direction. So starting with the x, we see that the x component for F2 goes like this in the positive x direction, so we know that's going to be positive. However, F2y actually goes in the negative horizontal direction. So if we draw it out here, we actually see that that arrow is going downwards. So F2y is actually negative. So that is solving for the actual components, so that's the easy part. But keep in mind, we're now into vectors. So if you guys were to solve this, you guys have the correct answer. You have all the components. It says to resolve it into its components. You have all the answers, but this is not how you state that final answer. Remember, we're in vectors now, so we have to state it as a vector. So our F1, so since it's a vector, put the little arrowhead, is equal to, and then we're going to want to go squiggle brackets because we're dealing with vectors. So we're going to start with the x, so it's 200, positive 200, and since it's x, we go I. And then for the vertical, it's positive 346, so we go plus 346 times j, because it's in the vertical direction. We can end the squiggle brackets, and then we have to put the units. So these are all in newtons because it's all a force. So newtons. And then we do the same for F2. So F2 is going to be equal to squiggle bracket. We look at the x component first. So we got a positive 177. So we'll go 177 I. So now looking at F2, we write F2, again with the little arrow, is equal to squiggle bracket. And then we look at the x component, so we have 177. And since it's in the x direction, it's I. And now for the vertical direction, it's negative 177. So we go minus 177, and then vertical direction, so j, and the squiggle bracket, and then of course the unit is Newton. And since it's the final answer, we'll put a nice box around it to state that it's our final answer. And yeah, that's it. So again, this was an easy example. It was basically just to show you guys, keep in mind where we put the axis, because depending on where we put it, that's where we want you guys to take all your references from, is the axis we give you. It doesn't always have to be horizontal and vertical. And then again, the last thing for the practice, just remember those directions. A lot of you guys know that how to find the x components, like f1x is 200, that's no problem. It's determining whether it's positive or negative. Students not have trouble with, but more just forget. And I can't blame them, I was the exact same way. All right, so that concludes this example, as well as week one, I guess. So I just wanted to say that I hope that week one was kind to you. I hope these videos helped, because it's going to start ramping up now. But don't worry, I'll have lots of videos for week two and every week until the final, plus midterm reviews and final reviews. So yeah, I'll be here with you guys to see you guys through it. So thanks again, everybody, and I'll see you guys in the next example.